For the Now You Try problems, take some time to complete these problems on your own first before you continue the video. Now that you're ready to look through the solution, we're going to look at one example at a time. So to find the x-intercepts, we always start off saying the function value is equal to 0 and go from here. So f of x is equal to 0, which is equal to x squared minus 81. And when we want to find the solution using square root method, we want to always isolate the constant term by itself. So we can add 81 on both sides. To get 81 is equal to x squared. Once you have some perfect square equal to a constant, we can go ahead and take the square root. Make sure you have plus or minus over here because you should have two answers. And plus or minus 81 becomes plus root 81 becomes plus or minus 9, and that's equal to x. Therefore, the x-intercepts are 9, 0, and negative 9, 0. That's how we can go about it. And everything kind of expands on this structure and go from here. Now for part B, we want to set 0 to be equal to negative 2x squared plus 50. Again, I'm going to add 2x squared on both sides, just so I don't have to deal with negative coefficients all over the places. And here, to get the perfect square by itself, I would have to divide 2 on both sides, just so I can just get x squared by itself. And that's equal to 25. Once we have a perfect square by itself, we can go ahead and take the square root. And then we have x is equal to plus or minus 5 as a result. Therefore, our x-intercepts are 5, 0, and negative 5, 0. Moving on to part C. Part C is really very similar to what we did in part B if we had the same structure. So we get 0 is equal to 5x squared plus 21. Now to isolate the constant, I would have 5x squared is equal to negative 21. And if you didn't recognize it in the first step over here, I hope you recognize it now. If you think about what we're dealing with here, when we have a perfect square, or if we have some value squared multiplied by a positive number, this right-hand side over here, this should always be greater than 0, or greater than or equal to 0. If x is 0, we will have that equality. And because of this, if you see that this is equated to a negative value, you know we can't really solve for this. And even if you're thinking a couple steps ahead, we're really going to be taking a square root of a negative number. And as a result, we would say there is no real number solution. So we can conclude that there is no real solution. So for our graphing purpose for x-intercepts, we would say there is no x-intercept for this function. And that's entirely possible. This parabola is just not touching the x-axis at all. So that would be the solution for this one. Now moving on to part D, we want to again start off the same way to say x plus 3 squared minus 49 is equal to 0 and isolate the constant part. So I'm going to add 49 on both sides. And now I have a perfect square expression equal to some constant. So here I can go ahead and take the square root on both sides. Make sure you have both positive and negative values. So we get plus or minus 7 is equal to x plus 3. And this leads to two different linear equations. 7 equals x plus 3, or negative 7 equals x plus 3. So we would get x by subtracting 3 on both sides in both equations. So 7 minus 3 is 4, 4 equals x. Or negative 7 minus 3 would be negative 10, which is equal to x. So our x-intercepts in this case are going to be 4, 0, and negative 10, 0. Now moving on to part E, if we want to find the solution for this one, same thing as before, 0 is equal to the expression over here. To isolate the constant, I'm going to move this perfect square part to the left side by adding it on both sides. So we get 4 times x minus 7 squared is equal to 36. And again, you have a little bit more flexibility here when the leading coefficient is a perfect square, but here I'm just going to use a method to divide away the coefficient when it's not equal to 1, because the numbers will be easier to work with and keep track of from here. So if we divide 4 on both sides, we are going to get x minus 7 squared is equal to 9. And once we do so, we can take the square root, because I have a perfect square expression with variable. And we get x minus 7 is equal to plus or minus 3. And that leads to two equations over here. X minus 7 is 3, or x minus 7 is negative 3. As a result, we can add 7 on both sides to solve the equations x equals 10 or x equals 4 as a result. And then we can say the x-intercepts are 10, 0 and 4, 0. Lastly, in part F, if we want to find the solution, we would get 0 is equal to 6 times x plus 5 squared minus 20, and therefore 20 is equal to 6 times x plus 5 squared. And we would go ahead and divide away the 6 on both sides. And here there's no alternative way because 6 isn't a perfect square. And I did the same thing with part E, even though 4 is a perfect square. So you can see, looking at the part E over here, you have some flexibility when the leading coefficient is a perfect square, whether you want to square root this whole thing directly or you want to divide things away to work with one single value or smaller numbers. In this case, in part E, it worked out nicely because 36 over 4 is still a perfect square. It didn't make things any harder to work with. That's why I chose to divide away the 4 right away. And for any other case, when the leading coefficient is not a perfect square, always just divide away that leading coefficient so you don't have two messy numbers, one on each side. So once we divide, we're going to get 20 over 6, which can be reduced to 10 over 3, and that's equal to x plus 5 squared. Now that we have a perfect square expression on the one side, we can take the square root. And that gives me that we have plus or minus root 10 over 3 is equal to x plus 5. And that's where you can rationalize things. And that gives us square root of 10 over square root of 3. To rationalize it, we can multiply root 3 on both sides, and we know that's equal to x plus 5. And as a result, we will get square root of 30, which cannot be simplified anymore, over 3. That's equal to x plus 5. And to get x, we can subtract 5 on both sides and get plus or minus square root of 30 over 3 minus 5 is equal to x. If you want to combine the two terms, you can set 5 to be equal to 5 over 1 and then set the common denominator by multiplying 3 on both sides. And we would get plus or minus square root of 30 over 3 minus 15 over 3. And that's really the only extra step you would be able to do over here. And that's equal to x. And then to report our answers, our x-intercepts are going to be the positive root 30 minus 15 over 3 comma 0, or we can have the negative root 30 minus 15 over 3 comma 0. The number is messy, but as long as the steps are clear and you're doing the right steps throughout, this is perfectly fine to have this type of solution.